This question is about a student trying to throw a boomerang. So typically a boomerang, you've got it, it's like a U-shaped piece of wood. You throw it in the air and it flies and spins and then comes back round and then you try and catch it. So a student suggests this model for the displacement between 0 and 6 seconds. For the model, determine what happens at t equals 6. So I can work out the displacement at t equals 6. So that's going to be 9 times 6 squared minus 3 over 2 times 6 cubed. And we get 0. So what's happened? The boomerang has returned. And presumably been caught. Find the greatest displacement of the boomerang from O. So we have a function of t. S is a function of t, and it's going to be some sort of cubic. What we're interested in is the maximum value, essentially. So I'm going to find ds by dt. This is a variable acceleration question if you haven't worked this one out yet. If you were to find the acceleration, it would be dependent on t. So ds by dt is 18t minus 9 over 2t squared, and it equals 0 for stationary points. So then t 18 minus 9 over 2, t is equal to 0, and t is equal to 0. Well, that was when s is actually equal to 0 itself, or 9 over 2t is equal to 18. And I can times by 2, divide by 9, I'm actually going to get 4. So s equals 0 here, it's clearly not the maximum. Therefore, I need to, actually, am I asked to work out, okay, find the greatest displacement. So I'm going to actually now find out what s is. And it's going to be 9 times 4 squared minus 3 over 2 times 4 cubed. Which gives 48. Now the mark scheme seems very lenient, maybe because it's a mechanics question, I'm not sure, but it doesn't make you prove that it is the greatest displacement. So as long as you make like an argument that it must be the maximum, because that's clearly not, then you're okay. But I feel like, okay, I'm going to write that down. So this must be the maximum. Okay, I just think it is actually safest to just prove that it's a maximum. So I'm going to do that as well. And then find d2s by dt squared. Actually, that is the acceleration. And it's going to be 18 minus 9t. So you see here, we've got this variable acceleration. And when t equals 4, d2s by dt squared is going to be 18 minus 36. It's going to be minus 18 less than 0. So max. Hey, I personally would advise that. It's not in the mark scheme, but I just think it's good practice. Sometimes the question might not be clear whether it wants you to show it, but actually you will be penalized if you don't. So let's just play it safe. Finally, we're asked to find the velocity of the boomerang 1 second before the student catches it. Remember, they catch it after 6 seconds. Okay, part A, we showed that. So actually, it's when t is equal to 5 for both of these. And this question is just testing understanding of what the velocity is. Actually, it's the change in displacement over time, which we calculated before. 18t minus 9 over 2t squared. So when t is equal to 5, we get minus 22.5 meters per second. That's not surprising because it's coming back, remember. And a is then the derivative of velocity with respect to time, or in fact the second derivative of displacement, which I already worked out because I looked at the second derivative here. And when t is equal to 5, a is going to be 18 minus 45, which gives minus 27 meters per second squared. Nice.